Good evening, students. Today we are going to see about single stub matching. So in this single stub matching, today we are going to see how a Smith chart can be drawn. So today I'm with the help of a digital scribbling pad. I'm going to teach you how to draw a Smith chart. So first of all, the given question. So they ask you to find first SWR. Okay. So SWR means a standing wave ratio, and also they ask you to find the characteristics impedance Z0 for a quarter wave transformer. Okay. Then distance between the transformers. So distance between the transformer to be placed to get smooth line. Okay. So this is what we are going to find today. So the question consists of two parameters, as you know that. So the given ZL, which is equivalent to 75 plus J of 60 ohms. Then Z0, which is equivalent to 50 ohms. So this is the characteristic impedance of a transmission line. Okay. So they ask you to find characteristic impedance of a transformer, which is Z0 dash. So now how we are going to find the given values. Okay. So now the first step number 1. So as you all know that the given question ZL is equal to 75 plus 60 J60 ohm, comma Z0, which is equivalent to 50 ohms. So the first step is we have to find normalized load impedance. Okay. So normalized load impedance. So in order to find normalized load impedance, we have to divide our ZL by Z0. So by this we can find 75 plus J of 60 divided by 50 ohms. So which gives you 1.5 plus J of 1.2 ohms. Okay. So this is our normalized impedance. So in a graph, that means in a Smith chart, we can mark it as A. Okay. So this is our first step. So let's move on to a Smith chart. So I have taken the Smith chart in a form of Microsoft Paint. So you could see that. So here the Smith chart consists of two halves. So this is upper half. Okay. So this is upper half. So upper half. So where the ZL by Z0, which is so real plus imaginary. So in the bottom half, you know that the thing will be real minus imaginary. So in the given question, so we know that we have found out 1.5 plus j of 1.2 ohms. Okay, so the first step is to mark the real and imaginary value. So here in the x-axis, so if you compare our Smith chart with our regular graph, so here you could see a dark line, so in which there will be values are marked as 0.1, 0.2, 0.3 and all. So here, so here the center thing is 0.1 followed by 1.4. So you could see that, so this is our center, you mark it as a or name it as a 0. So from here you could see that this is 1.2, this is 1.4 and this is 1.6. So 1.1, 1.2, 1.3, 1.4. So this particular ring is 1.5. Okay, so this is our 1.5. So what we are going to do is, so for your understanding, so I am marking this particular point. So see here, I am denoting it as red color. So this is what the real value. Okay, then followed by the imaginary value. So in the given question, the imaginary value is 1.2. So 1.2 can be marked from the outer circle here. So this is our 1.2. So for your understanding, so let me draw with the another color. Okay, so here I take this color. So from here, so we could see that, so by drawing this, so this is the point. So this is how you have to mark the okay. So right now I have marked my impedance, normalized impedance value, which is nothing but, so you can mark it as 1.5 plus j of 1.2 ohms. Okay, so this is how you have to mark. So from this x-axis, from 1.5 I shaded like this, from the imaginary which is present in the outer circle 1.2 I created a dotted line. So both are intersected at a point, so that point is our normalized impedance. So here in this sum I am naming it as a P. Okay, you can name it as a P or A also. So now I am going to mark it as P. P is nothing but 1.5 J of 1.2 ohms. Now next thing is I have to draw a circle. Okay, so from O, P as a radius. So O, P as a radius, I have to draw a circle. Okay, so now I take see here. So now I have drawn a circle. Okay, so using a compass you can draw a circle. Okay, so see, so I have drawn a circle, so in which the S value, so this is the S value. You could see that it comes as 2.9. So here the sum S equal to 2.9. Okay, so now what you have to do is we have to find the distance. Okay, so we have to find the distance where we have to place the transformer so that we will get a smoother line. So here, so from OP, okay, so I supposed to draw a straight line. So from O via P, it has to goes okay. So this is, you can name it as a P dash. Okay, so when you zoom it, so you get the value of almost 0.19. Okay, so let me draw that once again. So from O along P, so I am drawing a straight line. Okay, so it almost intersects at the outermost wavelength as 0.019. Okay, so this is 0.019 lambda. Okay, so we have to find the distance. Okay, so here the particular thing, this is our D, so we are going to find the distance between these two. Right. So maximum of here, which is 0.25 lambda, so we can obtain the value by the difference between of 0.25 lambda minus 0.19 lambda, which gives you 0.06 lambda. So this is where the distance between the quarter wave transformer QWT. Okay, so now